Okay, and then in section 6.4, we started talking about inverse functions. So if I'm asked to find the inverse, remember that I start with y equals whatever they give me, 3x plus 11. My first step of finding an inverse is swapping x and y. So when I have y equals, nope, that's where y was, sorry. X equals 3y plus 11. And then I want to solve for 11. So I'm going to solve for y. So I will subtract 11 from both sides. I have x minus 11 equals 3y. And then I have to divide both sides by 3. So y equals x minus 11 over 3. Except instead of y, once we've found an inverse function, remember we can call that f with a negative 1 exponent of x, and we read that as f inverse of x. Now, if I want to confirm my result, totally different process. What we have to do is test f of g of x, or in our case, f of f inverse of x, and we're going to test f inverse of f of x, okay? And for this problem, I will work it out. For the next problem, know that I won't work it out, but I'll still end up getting the right answer. If I ever give the instructions of confirm your result or show that these are inverses, make sure that you show me all of the steps. So f of f inverse of x means that into f, I'm going to plug in my inverse function, which we just found was x minus 11 over 3. Well, that means that our f function, which tells us take 3 times our x and then add 11 to it, well, except this time our inverse function that we're plugging in is x minus 11 over 3. And then we start to simplify and a whole bunch of things cancel. In fact, everything cancels. So I only have x minus 11 plus that 11 outside, and sure enough, I'm left with just x. That's good. That's what I needed to be left with. Now we'll go through it for f inverse of f of x. Well, that means that if into f inverse I'm plugging in x plus 11, except it's 3x plus 11, there we go. And I am going to take 3x plus 11, and then I'm going to subtract 11 and divide by 3, just like my f inverse function tells me to do. Well, notice things cancel in a slightly different order, so my 11s cancel first and then my 3s, but sure enough, I still just have x by itself. Whenever you are testing to see if two functions are inverses, when you plug them both into one another, you need to end up with just plain old x. So then for problem number 7, I'm just going to take the time to find my inverse function. You can check my work on eBackpack to confirm and how I confirmed it. So we start with y equals 2x to the 7th minus 1. Swap x and y, equals 2y to the 7th minus 1. Solve for y. So I have x plus 1 equals 2y to the 7th. I'm going to divide by 2. And then to get rid of y to the 7th, I'm going to take the 7th root of both sides. So then my inverse function is the 7th root of x plus 1 over 2. And again, as I confirm, I have f of f inverse, and that just gets me x. You would want to show your work. And then f inverse of f, I just get x. We're A-okay. Next, section 6.5 is when we graphed cubic root and square root functions and talked about domain and range and transformations. So with problem A, I have a square root function. Our parent points for our square root functions, 0, 0, 1, 1, 4, 2, and 9, 3. You need to know those. Then we've got two transformations we have to apply. So we've got this a value of 9 out front, and we're subtracting 1. Those are both y-coordinate transformations. We have to do multiplication before we do subtraction. So I take 9 times each y-coordinate. So I get 0, 9, 18, and 27. And then I'm going to subtract 1 from each point because I'm moving down 1. So negative 1, 8, 17, and 26. I'm going to go ahead and plot those points. Make sure that you scale your axes appropriately so that you have room to fit everything. So I got each of those points plotted, and I scaled my x-axis by 1s, as we can see, and our y-axis by 3s to make sure I had room for everything. Notice I have an arrow going off to the right, but I don't have one going off to the left. Our graph stops at that HK value, which for us this time around is 0, negative 1. So that's going to help us figure out our domain and range. Remember, our square root functions, our domain and range is determined by our h and our k. Well, our input values, all of our x coordinates, we can only plug in numbers that will make our square root greater than or equal to 0. So things inside our square root, well, this time around is just x. So I have x is greater than or equal to 0 for my domain. I cannot plug in negative values under an even root. Our range is determined by that domain, and sure enough, the first y coordinate that our graph hits is -1. All other y coordinates are above it, so that means that our range is y is greater than or equal to -1. Our transformations that happen to our graph, well, we had that 9 out front, so that's a vertical stretch by a factor of 9. And then that -1 is a vertical shift down 1. And there we have it. Now an example or problem number 8b, this time we have a cubic root. Well, our parent points for our cube root functions you also need to memorize. We've got -8, -2, -1, -1, 0, 0, 1, 1, +8, +2. The transformations we apply this time, we've got that x plus 2 under our radical, and then we've also got that -5 attached. Doesn't matter which order we do these in, since our transformations, one applies to x, one applies to y. So I'm going to go ahead and do that x plus 2, but notice that this is going to cause my graph to move to the left 2. So I need to take each x coordinate and subtract 2. So that gives me -10, -3, -2, -1, and 6 for each of my x coordinates. And then my y coordinates, I'm going to multiply by -5. So that gives me a +10, +5, 0, -5, and -10. I'm going to go ahead and plot these points. You do the same, and we'll meet back. We've got our function graphed, and I've got all those points plotted. Notice I was able to count by ones for both my x and y axes. Our domain and range for all cubic root functions will always, whoa, still in the bold pen, that's okay. Hits the point across. All real numbers for domain and range. Now, our transformations, we can look at just our equation and figure it out. Our graph, we already said, moves left 2. That's a horizontal translation or horizontal shift left 2. And then that -5 out front causes 2 transformations. The fact that it's a 5 without the negative tells us that it's a vertical stretch by a factor of 5. And then the fact that it's negative tells us that it's a reflection. So vertical stretch, we said, by +5. We usually don't include the negative at that point, because then we say it here when we say reflection.